Hello everyone, welcome back to today's class. Dear students, in this class I am going to explain about another new topic, that is real numbers and their decimal expansion. After learning about this topic, let us solve few problems from the exercise 1.3. Real numbers and their decimal expansions. Under this topic, here first we have to learn about the types of decimal expansions. Dear students, there are three types of decimal expansions. Among that, very first one is terminating decimal. Here first we have to understand the meaning of terminating. Terminating means which has definite end. Now let us understand the definition of this terminating decimal. That is a decimal which have a finite number of figures. It means a decimal which have finite number of numbers. That is called terminating decimal. To make you to understand in better way, let me take an example. Here there is a rational number 2 by 5. Now let us divide 2 by 5, and you all are knows how to divide 2 by 5. Here 2 is less than 5, hence I cannot divide. Therefore let me take 0 point, and now I can consider a 0 here. Now I have 20. 5 fours are 20. Now subtract. I will get remainder is 0, but the quotient is 0.4. Now 2 by 5 decimal expansion is 0.4. Now tell me here, this decimal have finite number of figures or not, and how to identify that? See here, after decimal point how many digit is present. Here we can easily observe, and we can say that here there is only one digit. It means it is countable. There is only one digit. Hence it is finite number of figures it contains. Therefore we can call 0.4 is terminating decimal. I repeat again children, decimal which have finite number of figures called terminating decimal. Next let us move on to the second type children, that is non-terminating and recurring decimal. In the last slide we have discussed about terminating decimal, and there you clearly understood about the word terminating. I repeat again, terminating means which has definite end, but here we have non-terminating. Now I think you can easily guess what would be the meaning of non-terminating. Yes, which do not have definite end, or which never come to an end. That we call it for non-terminating. And what about recurring? Recurring means which repeats. Repeating number, we call it as recurring. So let us understand its definition first children. A decimal that will never come to an end. See, this is very important. If it comes to an end, it is terminating decimal. If it will not come to an end, that is non-terminating. And later on we have to check whether it is recurring decimal or not. And will repeat, this word also important, will repeat one or more numbers after decimal point in a predictable manner. So predictable means we can easily guess whether the number will repeat or not after the decimal point. Let me take an example here children. 22 by 7. You all are familiar with this number. It is the approximated value of pi. Now here if you divide 22 by 7, we get decimal expansion just like this. 3.142857, 142857, 142857, 142857, 142857, and it just goes like that for infinite number of times. Now observe very properly, children. After 3 here 142857, this repeated. Look at here, 5 times I have written here, and it continues for infinite number of times. So this kind of decimals we call it as non-terminating and recurring decimals, and this we can represent in another way that we see now. Note, see here, and this 142857 is repeating, hence which number is repeating, just over that number you have to write one line like this, and that line we have to read it as bar. I will show how to read this number, children. 3.142857 bar. If there is a bar, you have to understand this number repeats infinite number of times, and this decimal will be example for non-terminating and recurring decimal. Let me give another example also, children. Here 10 by 3. If you divide 10 by 3, we get that 3.333333, and 3 goes for infinite number of times. If you keep on dividing, you will be keep on getting remainder as 3. Hence this we can write it as 3.3 bar, and if there is a bar, you have to understand that this 3 repeats for infinite number of times. Next, let us move on to the last type, children, that is non-terminating and non-recurring decimal. About non-terminating, in the last slide we have discussed, which do not come to an end. Then what do you mean of non-recurring? In the last slide we discussed about recurring. Recurring means which repeats, but non-recurring means which do not repeat in predictable manner. Let's see the definition first here, children. A decimal that will never come to an end and will not repeat number after the decimal point in a predictable manner. So this kind of decimals are example for non-terminating and non-recurring. Let's see one example here, children. 0.10110111101110, so on. I have used the dots here. It means so it continues for infinite number of times. There is no end for this, and many children will be in confusion now. Hence understand clearly and in a proper way. And students will ask, sir, here one is repeated and here also repeated here also, then why we are calling it as non-recurring decimal? See, children, here I have used the word in predictable manner. It means here one repeated means one has to repeat continuously. Between one other digit should not come, or else if there is a 10, next also should be 10 only, next also 10, next also 10. Otherwise, if there is 101, next also 101 should be there, next also 101. See, 101 here repeated 2 times. It's not repeated from here onwards. So hence this kind of examples we can give it for non-terminating and non-recurring decimal. After understanding about these three, we have to understand one very important note, children, and this helps you in 10th standard in the chapter real numbers. The note number 1, terminating. Non-terminating and recurring decimals are rational numbers. It means terminating decimals and non-terminating non-recurring decimals we can express in the form of P by Q. Hence those decimals we can call it as rational numbers. But non-terminating and non-recurring decimals are irrational numbers. It means this is only this third one. Here what example we have taken here. This we cannot express it in the form of P by Q. Hence this is example for irrational number. Children, it is very important. Let me remind you again. The first type, I mean terminating. Second type, non-terminating and recurring decimals, we can call it as rational numbers because those we can express it in the form of P by Q. But this third type, I mean non-terminating and non-recurring decimal, we cannot be expressed in the form of P by Q. Hence it is example for irrational numbers. Now quickly move on to the exercise 1.3, children. And let's see the first one. Write the following in decimal form and say what kind of decimal expansion each has. Important it is, children. Let's see the first rational number. See, understand what is actually they are saying. They'll provide you a rational number and we have to divide that and find the decimal expansion and later on say what kind of decimal it is. So for that, now here I have 36 by 100. It means 36 I have to divide by 100. But I never go for normal division process. I can keep the answer directly. How it's possible? You also learn. See, whenever in denominator there is 100, it means powers of 10. If there is a 10, if there is a 100, 1000, 10,000, lakh, 10 lakh, crore, 10 crore. In that case, no need to do long division method. Directly you can keep the answer. And I'll show you how that is. Here, what is the numerator? That is 36. So directly write off 36. Now look at the denominator. In denominator, how many zeros are there? 2 zeros there. Hence, 2-digit backside you place a point. I mean keep a point. This is the first and this is the second. Hence you place a point here and write off here 0. Now the decimal form of 36 by 100 is 0.36. And this method you have to follow when only in denominator if you have powers of 10. Children, I repeat again, when you have 10, 100, 1000, 10,000, lakh, 10 lakh, crore, 10 crore. Only in this case you have to follow this method. If you have 200, 300 and all, you should not go for this method, children. Now the decimal form of this is 0.36. Now you tell me which kind of decimal it is. It has definite end or not. See, after decimal point we have only 2 digits. We can count that. Hence it is example for terminating decimal. Very simple. Next, let us move on to the another one, children. 1 by 11. Now we have to go for normal division method. So let me divide 1 by 11. Is it possible to divide 1 by 11? No, because 1 is smaller than 11. Hence let me take 0 point and I am taking 1 0. Now I have 10. Can we divide 10 by 11? Still it's not possible. Hence I have to take one more 0. Now let me take one more 0 here. Now it has become 100. Now I can easily divide. 11 nines are 99. How much is the remainder? Again we are getting 1 is the remainder. So but we have already taken 0 point, children. Hence we can take 1 0. But it's not possible to divide again. But you have to keep one more 0 now here. Now again 11 nines are 99. Now what is remainder here, children? That is 1. See, for every time I am getting remainder is 1 itself. It means in quotient same numbers will repeat. 0, 9 will repeat for infinite number of times. And there is no end for this decimal. It means 1 by 11 decimal form is 0.0909 and 09 goes for infinite number of times. Hence this we can write it as 0.09 bar. Children, this I said, whenever bar is present, you have to understand that those digits will be repeated continuously. Now you tell me which kind of decimal it is. Is it terminating one? No, it's not terminating, hence it is non-terminating. Is same number of digits are repeating? Yes, 09 is repeating, hence it is example for non-terminating and recurring decimal. Next, let us move on to another one, children. That is 4 1 by 8. It is mixed fraction, hence convert it into improper fraction. Let's see how to convert this. This denominator 8 multiply to 4. 8 4s are 32. Now keep it in the mind, 32 and 32 add to the numerator. We get 33. And in denominator you must write 8 as it is. Don't forget that. I'll repeat again, children. 8 multiplied to 4. 8 4s are 32 and 32 add to 1. We get 33. 33 write it in the numerator and in denominator write 8 as it is. Now let us go for the normal division method. Let's divide 33 by 8. Now 33 is greater than 8, hence we can go for 8 4s are 32. Remainder is 1. Now let me place a point here and let me take a 0. 8 1s are 8. Now subtract, we get 2. Already we have taken decimal point, children, here, hence we can take one more 0. Now 8 2s are 16. Subtract, we get 4. Now already we have taken here decimal point, hence we can take 1 0. So 8 5s are 40. Now the remainder is 0. We have got remainder 0. It means it is terminating 1. So what is the decimal expansion of 33 by 8? That is 4.125. And it is, we call it as terminating decimal because it has definite end. Next, let us move on to the another one, that is 3 by 13. Go for division method. Here 3 we cannot divide by 13 because 3 is smaller than 13, hence let's take 0 and 0 point we wanted to take, children. So we take 0, now it has become 30. 13 2s are 26. Subtract, we get 4 here, and again we cannot divide 4. Already we have taken decimal point, hence we can consider 0. 13 3s are 39. Subtract, we get 1, and already there is a point, hence we can take 0. But now 10 is less than 13, again I cannot divide, so you have to place 1 0 here, just like that. Now we can take another 0 here, it will become 100. 13 7s are 91. Subtract, we get 9, and take another 0. 13 6 is 78, and we get 12 is the remainder. Take another 0. Now 13 9s are 117. Again the remainder is 3. See, in beginning also we had 3. Now also we have got remainder is 3. It means from here onwards, if you continue the division process, same numbers will be repeated. I mean 2 3 0 7 6 9 will be repeated. Hence we can stop at this stage. What is the decimal expansion of this number? That is 0.230769 and so on. Here we didn't get the remainder. Again we have got 3. From that you have to understand the same numbers will be repeat if you go for division process from here. Now is it terminating? No, hence it is not terminating. And think whether recurring or non-recurring. So same numbers will repeat, hence this we can write it as just like this, children. Just over this number you have to write bar. After that we can say it is non-terminating and recurring decimal. Next, let us move on to the another one, that is 2 by 11. Let's go for division process here. 2 we cannot divide, hence take 0 point and take 1 0. 11 1s are 11. So subtract, children. Here we get 9, and already we have taken point, hence consider 0. We have 90. 11 8s are 88. Subtract, we get 2, children. See, in the beginning we had 2, and now also we have got 2. It means if you continue the division process from here onwards, again this 1 8 will be continued, means 1 8 will be repeated. Hence this we can write it as 0.18, so on. Otherwise you can write it as like this also, children, 0.18. 18 bar. Now tell me which kind of decimal. This is not at all terminating, it is non-terminating, and 18 is repeating, hence it is non-terminating recurring decimal. Next, let us move on to the last problem of this video, children, that is 329 by 400. Let's go for the division process. 329 is smaller, hence take 0 point and consider the 0. Now 408 is the 3200. Now subtract those, children, we get 90. Anyhow, we have taken decimal point, consider 0. Now 402 is 800 and subtract, we get 100, and we have taken already decimal point, hence you can consider 0, children. Now 402 is again 800 and subtract, we get 200. Now already we have taken decimal point, take another 0. 405 is 2000 and we get remainder is 0. When remainder is 0, it gives definite end. So its decimal expansion is 0.8225. So now tell me which kind of decimal it is. That is terminating decimal, because we have definite end. Dear students, I hope you have understood this one, and very important one from the point of examination. Practice very well, and the next video we come up with other problems. I hope you got it. Thank you.